Atoms holding hands. An introduction to chemical bonding. Everything around us is made of tiny particles called atoms. These atoms are the fundamental building blocks of all matter, from the air we breathe to the food we eat. They are so small that millions of them could fit on the head of a pin. Atoms are like the building blocks of matter. Just like how bricks come together to form a house, atoms join to create everything we see and touch. They combine in various ways to form different substances. They're super small, but they can join together to make bigger things, like molecules. Molecules are groups of atoms bonded together, and they can be simple, like oxygen, or complex, like DNA. How do these tiny atoms stick together? What makes them form these connections? The secret lies in the forces that act between them. The answer is chemical bonds. These bonds are the glue that holds atoms together, allowing them to form the vast array of substances we encounter every day. Chemical bonds are like special forces that hold atoms together. They can be strong or weak, depending on the type of bond and the atoms involved. Imagine atoms holding hands to form friendships. That's kind of what chemical bonds do. These bonds can be likened to friendships, where atoms share or exchange electrons to stay connected. These bonds are super important because they determine what substances are made of and how they behave. The properties of a substance, such as its hardness, melting point, and reactivity, are all influenced by the types of bonds it contains. Without chemical bonds, everything would just fall apart. The world as we know it would cease to exist, as atoms would not be able to form the structures necessary for life and matter. Let's talk about one type of bond called an ionic bond. Ionic bonds are fascinating because they involve the transfer of electrons between atoms, leading to the formation of charged particles called ions. You know how magnets stick together because of opposite poles? Ionic bonds are similar. Just like magnets, the attraction between opposite charges is what holds the atoms together in an ionic bond. In an ionic bond, one atom gives an electron to another atom. This transfer of electrons results in one atom becoming positively charged and the other becoming negatively charged. This creates two ions, one with a positive charge and one with a negative charge. These ions are then attracted to each other due to their opposite charges. Just like magnets, these opposite charges attract and form a strong bond. This bond is what keeps the ions together, creating a stable compound. Table salt is a great example of an ionic bond. The salt we use every day is made up of sodium and chlorine atoms that have formed an ionic bond. Sodium gives an electron to chlorine to form sodium chloride. That's table salt. This simple yet essential compound is a perfect illustration of how ionic bonds work in the real world. Now let's move on to covalent bonds, a fundamental concept in chemistry. In a covalent bond, atoms don't give away electrons, they share them with each other. Think of it like two friends sharing a toy, both benefiting from it. Water is a perfect example of covalent bonding in nature. Two hydrogen atoms each share an electron with an oxygen atom, forming H2O. This sharing creates strong bonds that hold the water molecule together tightly. Covalent bonds are essential for life and its processes. Many important molecules in our bodies, like DNA and proteins, are held together by covalent bonds, ensuring stability. Finally, let's explore metallic bonds. These unique bonds are what give metals their special properties. Metals like copper, gold, and silver are shiny and conduct electricity. Their luster and ability to conduct electricity are due to the nature of metallic bonds. Why? Because of metallic bonds. These bonds are different from ionic and covalent bonds. In metallic bonds, the atoms share their outer electrons with all the other atoms in the metal. This creates a strong bond that holds the metal together. Imagine a sea of electrons flowing freely around a bunch of positive metal ions. This electron sea model explains many properties of metals. This sea of electrons makes metals great conductors of electricity because the electrons can move easily throughout the material. They can carry electric current efficiently. It also explains why metals are malleable. You can hammer them into different shapes without breaking them. The electrons act as a cushion, allowing the metal atoms to slide past each other without breaking.